Hello everyone, welcome to new video of MATLAB programming, and in this session we're going to explore more the matrix multiplication function, because it's very fundamental to engineering field and data manipulation. With that said, in previous video we learned how to do the matrix multiplication, but there are times when you need to multiply matrices element by element. And if you remember, we covered this feature before in vectors, but because it is important, let's explore that here in matrices as well. Let me start by giving you an example. Imagine that we have a class of 16 students, and we wanted to record their presence in class in 2 days. So the first day we want to see from these 16 students how many were present, and on the second day we wanted to see how many students were present on the second day. So if the students are present, we indicate that by 1, and if they're absent, we indicate that by 0. Therefore, let me create the class. So I call it class equal class first day equals 1 0 0 1 1 1 1 0 0 1 0 1, and the last one 1 1 1 1 1. Okay, so the class first day, it means that the first student was present, the second one was present, the third one was absent, this way. So this is the first day presence matrix. And the second day, we call it class second day equals 1 1 0 0 0 1 1 1 1 1 0 0 and 1 1 1 and 1. Okay, so this is also the class on the second day. So the students were like present that day as well. Some students were present and some were absent. Now what we want to do, we want to see how many students and which ones were present the first day and the second day. We know that if we multiply these two matrices, let's do it actually. So the class first day multiplied class second day. If we do that, you see that it returns a very different result, because it just performs the routine and the normal multiplication of matrices. What we are after though is multiply these elements, these matrices, element by element, so we can see which ones were absent and which one were present, because 1 multiplied by 1 is going to return 1, which indicates that the same student, because this one is exactly the same student as this one. So this way we can understand that which students were present and which students were absent. In order to do that, we need to do the multiplication element by element. So the way that we do that is by, let me clear the screen first. So we can say class, or I can double click it here. So the class the first day, the class the second day. Okay, so I return these. And now what I do is class first day dot multiply. If you remember, putting dot before the algebraic function makes that into an element by element multiplication. That's something that really we want. So class second day. So the class second day, and we put dot in multiplication. Now if I do that, you see that the result now shows that the first student were present the first day and the second day. And we can just see that these students were either present the first day or the second day, but not both. This type of multiplication is not as frequent as the normal multiplication, but there are times in engineering field that you need to perform such activities, and it's good to know that you're able to. Let me clear the screen. The next example that I'm going to show you is very useful, and there are a lot of times that you need to perform this operation, and I feel that it's a perfect time to explain it. What we're going to do is to find the summation of all elements in a matrix. If you remember in vector, let me create a vector called 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so I created a vector with 8 elements, and if you remember in vector chapter, we learned that there is a function called sum, and what sum does is when you pass a vector into it, what it does, sorry, I misspelled it. So if I return the name of the vector into some function, what it does, it creates a single number which happens to be the summation of all elements, right? Okay, how about when we have a matrix? So let me create a variable called matrix and put a matrix in it: 1, 2, 3, 4, 5, 6, and 7, 8, and 9. Okay, so I created a matrix 3 by 3 matrix, and I need to know how to find the summation of all elements. Let's try the sum function here and see what happens. If I say matrix, and if I pass that, you see that we only have, and as you see, we don't get one single number. Instead, we receive 3. And if we look closely, we see that this 12 is the summation of 1, 4, 7. This 15 is the summation of 2, 5, 8. And the same with 18. So what MATLAB did here is to return the summation of all columns respectively. So the sum function did not create the same result as vectors, and that's normal because we're not dealing with vectors, we're dealing with matrices. But there is interesting result here. If you look at if you pay attention here, if you look closely, you see that the answer now is a vector indeed. We didn't get a single number as here, but we received a vector, and the vector is summation of all columns. What we can do is now sum these 3 numbers together, right? Because we do have a vector here. So if I put sum ands, if I do that, you see that now I received a single number, which is the summation of these 3 numbers and also the summation of all elements here. Therefore, a shortcut to do that is to use sum twice. So sum, and again, sum of matrix, right? Now, and another, okay. So now I do have a matrix, the variable called matrix, and it is a matrix indeed as well. So what I do is to pass summation twice, and look what happens when I hit enter. The result is again 45, the same as the one that we received here. So what I wanted to explain here is that if you want to find the summation of all elements in a matrix, maybe it is 1000 by 1000, you cannot just use a calculator or or type them one by one and then do the summation again to do this. Summation again to find the last result. What you can do is to use this function and find the total summation. Let me clear the screen. and give you another one. So I call it A. 1, 2, 3, 4, 5, 6. 5 is good. So 5, 6, 7, 8, and 9. And 4, 5, 8, 1, and 0. Okay. Now I created a matrix which happens to be 3 by 5. Now if I wanted to find the summation, one way is to do the way that we learned was to do that summation twice. So if I simply pass A into two summations and do it, the result is going to be 68. And if you do it by a calculator out of MathLAB, you see that the result is always that it is indeed the correct answer. With that said, I see you in next video.